Today we are going to be solving quadratic equations. However, this time we don't have to graph the equations. We're going to find these x-intercepts, or these solutions, by using this zero product property. Well, the first thing you're going to have to do in order to use this is have the quadratic in the factored form. And the first few problems you do tonight, they'll be in this form. So we need to figure out what is this zero product property. Well, zero is just the number zero. Product means you're going to multiply, and we're multiplying by an expression or a number. It doesn't matter what number you multiply 0 by, you always get 0. And that's the concept we're using here. You see, this is one number right here. X minus 1 is one number, and we're multiplying it by another number right here, x minus 5. And we're getting it equal to 0. So what we're going to do is we want to find the number that makes, for x, that makes this 0. So the way you're going to do it is you're going to take the expression, x minus 1, and you're going to set that equal to 0. Do the same thing with this other one, x minus 5. Set that equal to 0 as well. And you'll end up finding the values that make each expression equal to 0. Here, if we add the 1 to both sides, we end up getting x equals 1. And it makes sense because you see, if you plug in a 1 for x right here, 1 minus 1 makes 0. It doesn't matter what this number is, because 1 minus 5 makes negative 4, but 0 times by negative 4 is going to equal 0. So that's one of the solutions. Over here, if I add the 5 to both sides, I'm going to end up getting x equals 5. And so those are the two solutions. And you can see how they work. If you plug in 1 again for this x, 1 minus 1 equals 0. And then 1 minus 5 equals negative 4, as I had mentioned before. And either way you do it, you end up with 0. If I plug in 5 for x, I get 5 minus 1, and I have a multiplied by, and then 5 minus 5. We do the work there, we have 4 times by 0, which still equals 0. You see, either way you do it, you're still getting the same answer. So those are the two solutions. So these we call x-intercepts, we call them roots, we call them zeros, we call them solutions of the quadratic. And that's what we have. So 1 and 5, I'll put it in my solution set. So that's all you're going to be doing. So the problems that are already set up for you go pretty quick. You just take the expression, x minus 2, you set it equal to 0. And you solve. So we end up adding the 2 to both sides. We get x is 2. That's one of the solutions. But there's one more. We also have x minus 9 equals 0. And we go ahead and solve. And again, the reason why we're setting it equal to 0, this expression, is because we want to find the value of x that makes it 0. And you see, when you go ahead and solve, you end up with 9, and it makes sense. 9 minus 9 is 0. So those are our two solutions, 2 and 9. Those are the values of x that make it equal to 0, because that's what it equals. Over here, same sort of thing. X minus 2 equals 0, and you got x plus 4 equals 0. So when we go ahead and solve, we have to add the 2 over here. Over on this side, we have to subtract the 4. And we end up with our two answers. X equals 2 and x equals negative 4. The two solutions, 2 comma negative 4. So that goes inside a brace to represent a solution set, the values of x that make this statement true. This next one's a little bit tougher because of this 2x here. So remember, you've got 2x plus 1 equals 0, and over here we've got x minus 6 equals 0. So we're setting them both equal to 0. Doing some work there, you got to subtract the 1, and we have this 2x equals negative 1. Over on this side, we add the 6, and we have a x equals 6. This one's solved for us, but over here we have one more step. So notice that you end up having to divide by 2, and you have a fraction. Look at the fraction, negative 1 over 2. So x equals negative 1/2. And so we write the answer as an ordered pair, negative 1/2 comma 6. Oops, not a parenthesis though, definitely a brace, because this is a solution set, not an ordered pair. Well, over here on these problems, we have to factor first, and then we can use that zero product property. And so taking a look at the first one here, we have x squared minus 3x. So here there's just a common factor of x. We don't have the two sets of parentheses, but we're taking that x out, and we've got an x minus 3 left over. So now we've got the two factors. You set them both equal to 0, and you solve. And so over here we just have the answer already. Over here we have to do one extra step. you have to add the 3 to both sides. So we end up with x equals 3. So there it is, 0, 3 as the solution set. Well, this next one's a little bit tougher. It factors as two binomials because there's no common factors. So we start with x and x to make x squared. Numbers that multiply to make 3 are 3 and 1. Both addition signs because they multiply to make a positive 3, add to make 4. Well, from there, you're setting those factors equal to 0 to find out what the solutions for x are. And so we set the x plus 3 equal to 0, and we set this x plus 1 equal to 0. And then we go ahead and solve by doing an opposite operation. So here we're taking away 3, here we're taking away 1. So we get our answer of x equals negative 3 for the one, x equals negative 1 for the other. So negative 3, negative 1 are the two solutions. Well, over here it's a little bit different because we've got a minus sign right here. So remember, outside and inside terms are now subtracting to equal a 5x. So when you go ahead and factor that, again, you're trying to figure out the numbers that subtract to make 5, but multiply to make 6. 6 and 1 would work. To make a positive 5, we need more positives than negatives. So it's a negative 1 and a positive 6. So from there, we're not done, though. We now have to solve for x. What are the values of x that make it equal to 0? Well, you're going to set x plus 6 equal to 0 and set that x minus 1 equal to 0. So you go ahead and do some work there. Subtract the 6 from both sides. So you get x equals negative 6. One of the answers there. Add the 1. You get x equals 1. So those are our solutions. Negative 6, 1. 2x intercepts. Looking at the next one here, we're going to go ahead and factor that. It factors down to an x plus 8 and an x plus 3. In order to multiply to make a positive 24, we knew both signs had to be positive. Outside and inside terms need to add to make 11, and 8 and 3 do. Well, you're not done there. You still have to solve for the values of x that make it equal to 0. So you're setting both factors equal to 0, finding the values that make x equal. Once we find the values of x, that when we go ahead and add the 8 or add the 3, we get 0. So here, we have to do an opposite operation. So we have to subtract 8 from both sides. Over on the other one, we're doing another opposite operation. We're subtracting 3. So we end up with x equals negative 8 for one, x equals negative 3 for the other. So those are our two solutions. We'll put in our solution set. Next one here, we go ahead and factor. Now this one's not so bad because we have a prime number. 11 times by 1 is the only number that multiplies to make 11. To make it a negative 12 for the outside-inside terms, they needed to both be negative. So from there, though, once you've got the factored form, you're going to set the factors equal to 0. And this will give us the two values of x that when we multiply by the other factor, we get 0. And so we go ahead and add 11 to both sides. Over here, we're adding 1. And this gives us our two values of x. So x equals 11 for one, 1 for the other. And so those are our two solutions we put in our solution set. Well, look at the last one here. Numbers that multiply to make 65. So if the number's really big like that, you might just take it and break it down. We know 5 times by 13 multiplies to make 65. And sure enough, those two numbers do add to make 18. But we want them to subtract to make 18. And so got to think about this a little bit further. And so when we go ahead and try another value, well, we only have couple more options there. Let's see, 15 makes that 65. We have 65 and 1, and that's it because that's prime. And so we can't get numbers that multiply to make a negative 65 that add or subtract to make 18. So in this case, we have no solution. So we can't do this work. We can't subtract because of this minus sign right here. The outside and inside terms need to subtract to make 18. However, when we go ahead and factor this 65, we find that we only have 15 or 5 and 13 that multiply to make this 65. And when we go ahead and try to factor any further, it doesn't work. So our only factors are 1, 5, 13, and 65. And we just can't get the factors to subtract to make 18. So this one has no solution. Or at least no rational solutions. No rational solution. And so that's our answer for this problem. We'll just call that our answer right there, and we'll move on to the next part. So part 2 will have a couple more problems like this and a word problem that deals with projectiles.